Hi guys, today's lesson is on the relative atomic mass and also isotopes. So let's get started. The first one says calculate the number of protons, electrons and neutrons in bromine. And to do that, we need to look back at last lesson, and this is where we calculate the protons, electrons and neutrons of an atom. Now the protons, these are always the atomic number, and if you look at a periodic table, you'll see that that's 35. Electrons are always the same as the protons, so if the protons are 35, so are the electrons. And finally for neutrons, that's the mass number minus the atomic number. So 80 minus 35, and that comes out at 45. Now the next question, what is the centre of an atom called? That's the nucleus. And finally, what is the definition of an element? Well, elements are made up of one type of atom only. Okay, or they're only made up of one type of atom. So today we're going to look at the relative atomic mass of an element. And this is the average mass of every isotope of that element. And we're going to look at what an isotope is on the next slide. But before we look at what an isotope is, it's interesting to look at chlorine. Now chlorine's relative atomic mass is 35.5. Where does this 0.5 come from? Because you can't have half a particle. Well, an isotope is an element with the same number of protons but a different number of neutrons in the nucleus. So if we look at chlorine, we'll see we've got these two isotopes. You've got chlorine 35 and chlorine 37. Now if I had, let's for example say a lump of chlorine, 75.8% of that lump would be made up of Cl35, and the other portion of that would be made up of chlorine 37, 24.2% of it in fact. But I want to know what the relative atomic mass of the whole thing is. Now to do that we need to do a calculation, and that's how you do it. You do the relative atomic mass equals the sum of the isotopic abundance, so how much of a particular isotope you have, times its mass number, divided by 100. Now this 100 is all the abundances added together. Now it should always be 100 because you can only have 100%. Now if we go through this with chlorine, we should get 35.5, which is what you see on the periodic table. So let's have a go. So relative atomic mass is the sum of the isotopic abundance of each element multiplied by its mass number divided by 100. So for this one, it would be the isotopic abundance, 75.8, times its mass. Its mass is the one at the top, times 35. And we're going to add that to its other isotope, isotope 2. And that's the atomic abundance of that, which is 24.2, times by its mass, 37, divided by 100. And indeed, if you do that, you will get 35.5, which is the relative atomic mass of chlorine. Now there's some for you to have a go at here. What you need to do is use that equation to calculate the relative atomic mass of each element, looking at its isotopes, its abundance, and the masses of each isotope. So pause the video and then unpause for the answers. If we have a look at question 1, lithium, if you remember the calculation, we need to use the mass of each isotope and the abundance of each isotope. So the AR of lithium equals 6, the mass, times the abundance, 7.6 for the first isotope, added to the second isotope, which is 7 multiplied by 92.4, and then divide all that by 100, and you'll get 6.9, or rounded up to whole number, you'll get 7. And that should be the same in the periodic table. So if you want to check any of these answers, look at the periodic table and the number should be the same. Right, let's have a look at number 2. Number 2, copper. So the AR of copper equals 63 multiplied by the abundance of that isotope, which is 69.2, added to the second one, which is 65 multiplied by 30.8, divided by 100. If you look at that one, you should get about 63.5. Let's have a look at the third question. So to calculate the AR of bromine, it would be 79 times 50.7 added to 81 times 49.3 divided by 100, and you should get 80 when you round up to the nearest whole number. Okie dokie. Quite straightforward. If you have more than two isotopes, it doesn't matter, it's exactly the same principle. You just do the third isotope, or even the fourth if you need to, divided by 100. Now I'm going to leave you with 4 questions to have a go at. Remember to put some comments in the comment box below if you need some more support or you're struggling with any aspects of the video. See you later.